This is George Noble from GG Noble Tutoring. Today this is part 1 of a series of 3 on deriving the equations of motion. Equations of motions, parts 1 of 3. First, we need to define the variables, and they are time for TO. TO is initial time. X equals x to t equals position as a function of time. X naught equals initial position. V equals v of t equals velocity as a function of time. V naught equals initial velocity. A equals a of t equals acceleration as a function of time, with a naught equals initial acceleration. Case 1, constant acceleration, where t naught equals 0 seconds. A equals dv dt equals a naught. That's the equation for acceleration. That implies the integral between t and t naught for d v of t is equal to the integral of t to t naught of a naught dt. That implies velocity is equal to a naught plus v0. Next, v equals dx dt implies v dt equals dx. That implies the integral of t naught to t of v dt is equal to the integral of t naught to t of dx. And that implies that a naught t squared over 2 plus v naught t minus a naught t naught squared over 2 plus v naught t naught, and that term goes to 0, equals x of t minus x of t naught. So we have the result: x of t equals a naught t squared over 2 plus v naught times t plus initial x naught. Next, we define the relationship between velocity, position, and acceleration. This relationship is independent of time, and we derive it as follows: dv dt equals partial derivative velocity with respect to time times dt dx plus partial derivative velocity with respect to acceleration times dA dx. That last term goes to 0 because dA dx equals 0 since acceleration is constant. This term can be rearranged. Partial derivative velocity with respect to time times 1 over dx dt plus partial derivative of a velocity with respect to acceleration times 0. So we have dv dx equals a naught times 1 over the velocity, since dx dt equals v. This can be arranged with apologize to mathematicians, as these functions have to be continuous. dv dx equals a naught dx. So we can take the physicist approach and integrate right away and say t naught integral of v dv between t naught and v is equal to the integral of a naught dx between x naught and x. So that implies v of t squared divided by 2 minus v of t naught squared divided by 2 equals a naught x minus a naught x 0. So this can be finally rearranged to v squared equals v naught squared minus 2a naught times the difference between x and x naught. Well, thank you very much for watching, and I hope you found this derivation useful in your physics.